What's up, hackers? Happy Saturday. Welcome to Saturday Hacker Day. My name is Taggart, and today we have a lot going on. But as always on Saturdays, we are going to start with the cyber news. And so, up first, we have to talk about Felina. Good to see everybody in chat. Yeah, we have to talk about Felina. We talked a little bit about it on Tuesday, but it now has a CVE, right? CVE 2022-30190. What is this thing? It's really two issues, honestly. It's not a single vulnerability. It's two issues. So issue the first is the way that Microsoft handles these things called URI schemes. Basically, when we think about URI schemes like HTTP, HTTPS, right? There are a bunch of different ones that tell a computer how to handle a URL of some sort to open it in one application or another. So Microsoft has a ton of these reserved. One of them is this thing called MSDT is what the URL scheme looks like. And essentially what that will open up is the Microsoft Diagnostic Tool. And if you've ever worked with Windows and you've clicked on, or something went wrong with your computer, right? And you clicked on troubleshoot this issue or troubleshoot this problem. That thing that happens next where it says we're troubleshooting the problem, that's the Microsoft Diagnostic Tool. It's usually meant to be run in that specific scenario, or it's meant to be run by Microsoft diagnostic technicians. However, the way that it runs, it has these diagnostic wizards that it connects to, and you can run it from the command line. Here's where the problem lies. One of these things, the diagnostic compatibility wizard, I believe, had the ability to run arbitrary PowerShell scripts. And so what you could do basically is write a URI that would make the computer execute the diagnostic tool right from the browser, or importantly, from a malicious document, and then execute this diagnostic tool, run whatever PowerShell you wanted. Bob's your uncle. You've got yourself remote code execution. So that was pretty rough. So it's kind of two things. It's the way that the diagnostic tool is working. That's one. But it's also the way that Microsoft is handling these URI schemes. Okay. Now, for the first part of this, the diagnostic tool, Microsoft has not released a patch, but they have released a workaround, which is basically to disable the diagnostic tool entirely, which is okay, I guess, except that all of your users, if they ever do click on that troubleshoot this problem button, are just going to get an error, right? It's not going to work at all. So it's a little ham-fisted if you ask me, but as long as there's some sort of defense, then great. There are also, I will say, some solid detections for this if you have the ability to do real detection engineering in your environment. The tells for this are pretty solid in terms of looking at protocolhandler.exe and what that launches, and diagnostic host.exe, what that launches. So there are good detection rules that you can find, Sigma rules and the like, available for this. That's part one. Part two, though, is this URI scheme thing, and that is just not going to get fixed. And in fact, we're already seeing this attack research evolve. And we're seeing some exploits that involve the MS search vulnerability, or the URI scheme, I should say. And we're also seeing, so I've played with some that key off of Microsoft Excel or Microsoft Office URI schemes that allow you to open malicious content from the network, right? Macro-enabled documents even. So this is just not going to get fixed, right? It's a feature, literally. It's a feature of the operating system. It's something that we have to be aware of as defenders, that we have to look for this kind of behavior. And it really speaks to the importance of behavioral level detections in environments. You have to have that deep level of visibility into your environment in order to protect against stuff like this, because, friends, the Windows operating system is never going to run out of these kinds of weird gotchas. And by the way, not just Windows. Linux has all sorts of funky stuff going on inside of it too, and Mac OS, and the visibility there is even worse. So we have to do what we can to get eyes on the actual behaviors that are occurring on the system. And Felina is a fantastic exemplar of that need. Okay, the other story I wanted to talk about, and this was, of course, it broke, late in the week, was Atlassian came at us with an absolute barn burner. This thing has a CVE 2022-26134, and what we're talking about here is a no authentication remote code execution vulnerability in Atlassian products, specifically Confluence. And if you're not familiar with the Atlassian suite, Confluence is like Wikipedia, but you pay a lot of money for it. It's an internal documentation tool, essentially, right? Where you can keep your documentation for all of your assets or your procedures, whatever it is. And then another Atlassian product called Data Center. Both of these are vulnerable to this attack. Now, there is a patch out for the Atlassian products, so that's good news. There are also some good detections for it. Rapid7 in particular had a really solid write-up on the detections for this and what the attack looks like and how it works. And the thing I want to call out about this is that, once again, we're talking about, if you look at the attack, you're going to see something that looks very familiar if you've been following cyber news for the last year, which is an HTTP request that involves a $ and a curly brace. And once again, we're talking about a Java application. And once again, we're talking about exploitation of something called OGNL, or Object Graph Navigation Language. If that doesn't sound familiar, Object Graph Navigation Language was the underlying syntax that allowed the Jindy exploit in Log4j, right? So the Log4Shell vulnerability was facilitated by the syntax of OGNL. So once again, we have another Java library that is parsing OGNL syntax and leading to this kind of remote code execution vulnerability. It's a little trite, it's a little glib to say toss it. But it does seem like it is creating kind of a wide attack surface area for products that are written in Java, already a bit of a tempting target for offensive research. But the important part of this story, at least for defenders, is that the patch is out now. Well, okay, so that's not the entire important part of the story. The patch is out, but it was disclosed to the public while it was already under active attack. So it is a proper 0 day, right? Checks all the boxes. We didn't have any warning. It's under active exploitation. Yes, there's a proof of concept, like all of them. It's the worst possible situation for one of these vulnerabilities. And so, yes, you need to get your patches up, but you should also be getting any of these Atlassian systems off of the general internet. Don't have them there. And if they were there, you need to do some investigation now, because you no longer have any guarantees that this thing wasn't hit. So you have to, if you had a product like this that was on the internet in the last, I would go back a few months, honestly, because we don't really know when this kicked off, and look for anomalous behavior on the thing and validate to your level of satisfaction that it is clean of malicious activity or any persistence. And that's kind of just how this goes if you have these machines that are exposed. I'll even go so far to say is that that's probably a good idea, even if your Atlassian products are internal only and you have a BYO environment with a VPN or something like that. If you have an environment like that where your remote users can connect into an environment, and from that, without a jump box or anything else like that, within the VPN, they can access Confluence servers or Atlassian data center servers, there's no difference, right? Because your BYO users could have picked up, or your remote users could have picked up something off of your network, brought it in, right? It's just like not taking your muddy shoes off in the house. And so you got to be aware of that as well. So if you have internal stuff, but you also have that sort of remote work BYO environment, you're also going to want to be aware of that. All right. So we have a bunch of stuff to do today. The first piece is we're going to finish finally the intrusion detection and intrusion protection system setups in the homelab. I finally figured out how to do the packet capture in Proxmox. It was totally stupid. There was this undocumented thing that happens with interfaces in Open vSwitch. I finally found it. Yes, Vanny, Atlassian already patched their hosted Confluence service. That's a good point. If you're hosted, you're solid. But this is on-prem, for sure. That's a good distinction to make. But yeah, Open vSwitch had this crazy issue with the way that it generated these interfaces that was messing us up. And finally, we got everything working. Like, I got it working half an hour after the stream ended 2 weeks ago. I was off last week, but 2 weeks ago, because I had to stick with the problem and I couldn't let it go. I finally figured it out. So I'm going to show you how this works finally. Today. We'll set that up and then we'll move on. I have this completely wacky piece of malware that I wanted to share with you all and work through in our lab, in fact, just because it was so weird. I'd never seen anything else like it before. And we should break it down and talk about what kind of things you might see in a day-to-day kind of analyst position that might look like this, and what do you do about it? So let's get started. Okay, I actually don't want to be in Cali for starters. I want to be over here. So Proxmox is up, of course. And I finally took the time to set up like tmux and everything in my jump box. So we're going to have a much easier time seeing commands run because I have a proper terminal that we can zoom into and everything. So I've got the sock over here, and I've got the Proxmox hypervisor host up over on the left. Can I do? Oh, I can. Okay, so even when I'm remote desktop, I can do my mouse spotlight. Very excited about that. Okay. So, let's recall what needs to happen. What we want to have happen is we want to create packet capture interfaces on actually 2 machines, but definitely the Suricata machine. So let me actually split this up and go into our SecLab Suricata machine over here. Cool. So we've got our SOC on the top, which actually does have a packet capture interface for Zeek, and then the Suricata machine is a separate machine. So, let's run IPA on both of these. Okay. You can see that ENS20 in both cases is intended. It's intended to be our packet capture. This one needs to be given promiscuous up, but I believe that Zeek takes care of that for me anyway. However, in order for this to work, we need to have in Open vSwitch, right? Open vSwitch is the virtual switching layer that Proxmox is using to create our network interfaces. In order for this to work, there needs to be what's known as a tap interface. And I couldn't figure out last time why I couldn't see any tap interfaces in my Proxmox. And so if we do list ports for the virtual switch that we're talking about, you'll see now that I have 2 tap switches, right? 105 and 115. And this 105, as we learned through quite a bit of molding, it corresponds to the IDs of the virtual machines that we're talking about, right? There's 105, there's the SOC, and then there's 115, which is the Suricata. So obvious after the fact, but in the moment, it was a little bit confusing. So what's the deal? Why is it that I have a bunch of these FWLN interfaces and some taps? What is the difference? The difference is the firewall option in Proxmox. Watch this. So I'm going to go over to my Suricata machine and take my packet capture interface, and I'm going to re-enable the firewall. Then I'm going to go back and run the list ports again. Look at that. I've lost the tap. It's become a firewall interface, which again makes sense after the fact, but nowhere was any of this documented as to the naming convention, at least that I could find. And so now let's now that we know that, we can disable the firewall option on that thing, and now we have the tap back. Okay, so the commands, I don't know if you remember this or if you're just joining us, but the commands are going to look a little bit like this. So it's OVS, VSCTL, and then it's like ID equals, we'll call it Surrey tap, get port, and then let me just copy that. And then we have to create the mirror. So we'll do ID. And actually, I will do a line break here. ID equals at m create mirror name equals isolation mirror. Select all equals true. And then the output port is going to be that at Surrey tab. And then we have to set the set bridge VMBR2 mirrors equals the at m. Hey, Bravo Charlie Romeo. Good to see you. Just joining some podunk town you happen across. Well, they're the best ones. Kieran, I always wondered what the greater than sign was in the terminal. It was a wrong key. Yeah, so what you're doing there is you're line breaking the command. And you do it with a backslash space, or space backslash. That allows you to line break commands. And you'll see that in a number of different places. In particular, you'll see it for like here doc syntax, which is kind of a fun thing to do. Okay. Now, what did I do wrong? Oh, right. It's dash space, right? And then like so. It's because you're sending the yeah. There we go. And so now if we do OVS VSCTL list bridge VMBR2, we'll see that we have a mirror. Why double dashes? So that's a really good question. So the double dashes are essentially separating the command inputs and outputs is what's happening. They require masks for service? That's incredibly good news. By the way, this is not about tech, but yo, reassess if you're, especially if you're in the United States, reassess where you are with COVID safety. Cases are pretty much rising at almost everywhere, and it's not like it was like 3 months ago. Okay, we have like here in LA, we have quadrupled the positivity rate. And yes, the hospitalizations are still low, but they're climbing, especially like in San Francisco. I'm really worried about the people at RSA and besides San Francisco right now, because hospitalizations are climbing in San Francisco. This thing is not done. I hate to be the wet blanket about stuff like this. It really sucks. I had to pass on hanging out with J-Raz and Foot a couple days ago just because I have to travel soon and I have to be healthy for that travel. But yeah, please take care of yourselves. So yes, Angel, yes. Once you separate those, you only need to pass the arguments. OVS VSCTL works in a very weird way, and it works specifically in this way, where you're like passing multiple iterations of the command in this way. Oh, right. There's another thing I'm sorry. I totally forgot to mention this, and I totally forgot to set this up in Nightbot. But if you thought I wasn't going to give you a PWST coupon today, you were sorely mistaken. It is a general thing in Linux. It's just that you'll see it happen in different contexts. So, for example, in cargo for Rust, right? Because obviously I have to do that a bunch. If I do a cargo run, you can kind of see it right there. If I want to pass an argument after cargo, right? Because cargo is its own thing. But to pass arguments to the thing that cargo is running, I use the dash dash. Okay? And then after that come the arguments to the program that's running. So this is a thing in Linux. It's not just an OpenVS VSCTL thing. Right, so PWST, Practical Web App Security and Testing, is live. You can go get it right here if you use that affiliate link. I make more money, basically. It's really cool of you, but it says tonight only, but it's actually throughout the day. Use code HackerDay50. You get 50% off just for hanging out here. PWST got me to get Hyper-V on your computer. Yes! Hyper-V gang. Way to use a Type 1 hypervisor. Okay, so this mirror is created. So that's good news. And to confirm that it's working, I can run a TCP dump on ENS20, and you can kind of see this happen. I hope. Yeah, I did tab 115 I2. That's ARP and DNS. We can give it something real to see, though. There we go. As you can see, that is real packet capture. That is not just ARP. That's not just like broadcast and multicast stuff. Right? So we're getting real packet capture on there. That's actually happening. So we now know how to do packet capture through Open vSwitch. Finally. Here's the problem. It's not persistent across reboots. And since I power this thing off when I'm not using it, I need a way of making this persistent. So that's fine. And I also need to do it for the Zeek interface. So I need to change this up a little bit. So here's the Surrey tap, but I need to also, let me do OVS VSCTL list ports VMBR2 again, because I know that I need the 105, or sorry, the tap 105 I2. I need both of these, right? Kieran asks, what is the difference between Hyper-V and the likes of VirtualBox, VMware Workstation to spin up VMs? You know, I actually cover that in one of the videos in PWST. What is the difference between them? But briefly, here's the difference. Type 1 hypervisors are direct hardware virtualization. There is no software emulation layer between them. So they're taking full advantage of the CPU's capability of doing virtualized CPUs. That is a type 1 hypervisor. There's no... from the end user perspective, they're very similar, but what's going on under the hood is not. And that's the difference. So, like, VMware, like vSphere, ESXi, those are type 1 hypervisors because they're direct on the hardware. They're working, I believe they're working with KVM or QEMU under the hood. But with VirtualBox and with VMware Workstation, they are using a software emulation layer to talk to the CPU to do the virtualization. Okay? That means you do get a bit of a performance hit. You don't always notice it, but you will get a performance hit in certain situations. And there's certain things that you can integrate and can't integrate. It's one of the reasons why you have to kind of take extra steps with VMware and VirtualBox to do like USB integration or GPU pass-through, things like that. It's a little bit trickier. Type 1 hypervisors tend to be a little bit more performant, and that is why I prefer to use them. And Hyper-V is cool in that it is a type 1 hypervisor you can just have on your desktop for Windows 10 Pro and above. Windows 10 Home, you can't do it, unfortunately. Why more people don't use Hyper-V? I think, so there are a couple of reasons why more people don't use Hyper-V. One, that limitation I just said. And the other reason is that Microsoft kind of doesn't support it a lot anymore. They really don't want you using Hyper-V. They want you using Azure. And so they're kind of Hyper-V. I wouldn't say it's on life support, but it's not like new features are getting added to it. And that's definitely true for like server virtualization. They kind of want you to stop doing that. They want you to move to using Azure for your virtualization needs. And sometimes that makes sense, but sometimes it doesn't, you know? And so, but Proxmox also, because it's using QEMU under the hood, is a type 1 hypervisor. Okay, so obviously I have both of these taps here. And I need to use both of these. So I'm going to modify this command that I just had here. I'm just going to add another one. We're going to do ID equals sock tap get port, and this is going to be tap 105 I2. And then the output port, we can actually do, I'm pretty sure, we can select multiple output ports. Surrey tap, comma, sock tap. I believe that should work. Oh, dash dash. There we go. Oh. No, we can only do one. So that's fine. So what we'll do... can we do output ports? Okay, so this is, we'll call this the Surrey mirror. Oh, Theo, thank you so much for the raid, friend. How was your stream? And then we'll call this the sock tap. And that'll be 105 I2. Okay, so now if we do OBS, painfully learning Python, I hear ya. my next, so now that I'm done with PWST, I can finally go back on a learning phase, and my next thing is going to be machine learning, so that'll be fun. So more Python for me in the future. Right, so we're going to do OpenVSCTL list. Is it list? It's list bridge, VMBR2, and we have just the one mirror. Oh, right. Because we need to set the 105, we have to give it the sock mirror. Oh, hold on a second. I see what's the problem is. We have to do both of these at the same time. Oh, boy. That's funny. Okay, so we'll do... get port tap 105. And then... So what we're seeing here is that it's actually a huge pain to get these commands working all together. Basically, what we need to do is, so we're setting sock tap. And then after that, we're going to do ID equals Surrey tap, get port tap 115 I2. And then we're going to do ID equals M, create mirror. Name, actually ID equals Surrey mirror. Create mirror name. Create mirror name. Mirror select all equals true. Output port equals Surrey tap. And then ID equals sock mirror. Now we have to make the sock mirror. Create mirror name equals sock mirror. Select all. Oh, good. Select all equals Tor. That's not going to work. God. You know what? We're just going to write this out in like a script. Because this is too much. Okay, so it's going to be like... ID equals sock tap. Get port tap 105 I2. E equals Surrey tap. Let's do the socks first, and then we'll do the Surreys. Get port tap 152. Equals sock mirror, mirror name, sock mirror select all equals true. Output port equals sock tap. Just now realizing that say sock tab rather than sock tap. Okay. And then we're going to change this up to be Surrey. Now, this is actually kind of saving us some time later anyway, because, as I said, this doesn't persist across reboots, right? So basically what we're going to do is we're going to create a cron script that constantly checks for the existence of these mirrors, and if they're not there, then we're going to create them, basically. That's the plan. Surrey tap, and then technique says equal signs after those IDs. Yes, thank you. And then, yeah, that's the last part where we could do. Yes, this is Suricata. So basically, the fact that it's Suricata Angel doesn't matter super much right now. Basically, what matters is the fact that we are setting up packet capture interfaces in our virtual switch. Right, so for whatever purpose, it could be Zeek, it could be Suricata, Snort, whatever it is that you're doing packet capture for, this is kind of how you need to do it if you're using Proxmox, as we've discovered. So it's a huge pain, honestly, and I couldn't find good documentation any one place about it. So I have every intention of putting together something like maybe a course or a write-up or something about this whole process so that it is in one place, because it's the amount of stuff I've had to, put together to make all of this happen is pretty wacky. I wouldn't wish this on anyone. You think setting up Arch is hard? So finally, the last thing we do is set bridge VM BR2 mirrors equals, and then I believe what we can do is sock mirror Surrey mirror, like so. Port does not contain a column name whose name matches 115i2. Yeah, it's because there's a space where there shouldn't be. Mirrors are defining what interfaces to bridge. Yes, that is correct. So in this case, for the packet capture situation that we want, it's kind of like a many to one. Name argument does not end in the... Oh boy. So there we go. I'd like to thank Tmux for making this slightly less painful. Okay. So now... Now we have two mirrors. Do we monitor our outer interfaces the traffic has passed through these interfaces? I'm not sure what you mean by outer or inner in this case, Angel. We are capturing one of the, I'll say this, one of the ports that we just added to the mirror was the egress, ingress from the virtual switch. Okay, up to the WAN. So we are capturing the north-south traffic as well as the east-west traffic. Yeah, no, I got that part. It's just that in our network, it's slightly less clear what that means. But yeah, we are capturing both north-south and east-west because one of the ports that we're getting is the egress from the virtual switch up to the router. And yeah. This is underneath the router, I think is the way to put it, right? So that we're dealing with the router otherwise. Okay. But we are capturing the port to which the router is connected. Now, if we try sudo TCP dump IENS20 on the SOC machine, it would appear as though we're good. And we actually didn't even have to... Oh, right. I keep thinking, oh, I didn't set it into promiscuous mode. I don't have to. TCP dump does that for me. When I fire up TCP dump, it makes the interface into promiscuous for me. So that's why I'm seeing the packets across the board here. Okay. We are seeing packets. That is great news. If we want to confirm that sudo opt zeek bin zeek ctl, I'm going to do a restart on zeek. And then I'm also going to do some CTL. Oh, actually, if I do, what is it? Varlog Suricata. Yeah. You can see that we were getting Suricata data too. So the last piece, and Zeek, by the way, is already set to send data to our SOC, right? So the last piece that I just want to talk about for this is, how do we get the Suricata machine playing ball, sending data to the sending data to our SOC, because it's a separate machine, right? Well, I have Waza on this thing. Hey, Serto, thank you so much for the follow. What does the resource what does the resource utilization look like with this setup? Fine so far. I mean, that's part of what we're learning is what you need here. But let's look at what Suri is doing. I gave this thing 2 gigs of RAM, and it looks like it's doing okay with that. CPU usage is 20%. I can live with that. I might kick this up to 4 gigs of RAM. But really, like, not terrible. And then for the SOC is a monster. Well, comparatively speaking. This thing does have 8 gigs of RAM, and it is using it, but it also has 6 CPU cores, and it's purring. Aren't Type 1's basically bare metal performance? In some metrics, Cheeto. But there is one aspect where we could see some slowdowns, and that would be on disk IO. And that's basically because I'm using Rust disks, right, not SSD. What kind of hardware do you use to host the Proxmox? For the bajillionth time, it is an HP ProLiant DL380p Gen 8, and let's look at Starbase's full stats. Okay, so we've got 40 vCPUs, we've got 2 cores, 2 Xeon E5 2670s at 2.5 gigahertz, and 64 gigs of RAM, which I may be upping soon. And I have a RAID 1 that's about a terabyte. It's actually pretty small, but it's been okay so far in terms of storage. Okay, and in full transparency, this thing cost about $425 from SaveMyServer.com. It was a refurb model that I was able to pull from there, and honestly, it is more than paid for itself in terms of content and ability to do this kind of stuff. It was retrospectively a no-brainer investment. Yeah. It's a significant outlay of cash. But I don't run it all the time. I run it when we're doing streams and when I'm doing research. So like the power usage is like not terrible. I haven't looked at my power bill and had like cartoon eyes when I'm looking at the usage. So that's not so bad. Okay, it actually did cost a little bit more. All told, it cost a little bit more than 125 or 425 because I put it on top of an uninterruptible power supply, which was like another 100. But that's definitely worth it, right? I did that for a couple of reasons. One, obviously, if something happened with the power, this is a really old house, so if something was funky with the power, I didn't want to, have the machine go down during a stream. But also, because the UPS is doing voltage smoothing, right? I don't worry about the weirdness of the wiring in this house potentially damaging the power supply in any way, or potentially any other components. That's just like, you know, data center 101. Have a power backup. Okay, so right, we need to get the Suricata data going over to our SOC. And the file that we need is this file called eve.json. This guy right here. So we have a couple of options on how to do that. Yep, it is. Because the reason we want the raw angel is because Waza has its own rule set. I mean, we want both, I think. But I want to start with that. So let's log in here to the SOC. But I do like that I can, if I wanted to, I could pull the Suri logs as well. All right, our SOC is purring. Oh, also, I didn't. SSH, seclab, Ansible. There is one thing I need to do, which I totally forgot. So I have found weirdly that when I power off the lab and bring it back up, for whatever reason, certain machines, the Windows machines, like the Waza, I think it's just like the order of boot, that the Waza agents hang on the Windows hosts because I don't think the SOC is up ready to receive them yet. And the only way to get that to fix is to restart Waza across the board. So I have... I know I have it in here. I know I've done this. Yeah, restart waza.yaml. Easy days. So basically, this just goes and hits the Windows hosts. That's fine. I know that server I don't have up. That's fine. But everything else, it's going to restart the Waza agent and should clear this disconnected state from all but the web server, I think. But notice that Suri is active. And we're going to open the configuration for this agent. Global configuration is good. Log collection. So I can either do this by group or do it manually. It's pulling auth, it's pulling depackage. Okay, so if I want to pull that Eve JSON file, what I'm gonna do, awesome. Our agent should be good now. Go back to agents. Yeah. This machine, I believe, is off. Yes, it is, which is fine. But if I want to start collecting that Surrey data, I am gonna sudo vim etc. No, what is it? Etc. It's not waza. Or no, is it var? Dang it. Var OSSSec. Yeah. Shared. Or no, etc. Shared agent.conf. I believe. Just etc then. OSSec.conf. There it is. Okay, so here's the OSSec config stuff to pull, right? And so we're going to add a config here. And it's a local file, that is true. But it is not syslog formatted. It is JSON formatted. And we're going to do var log suricata eve.json. Yep. Ever tried Cribble to parse your logs? I've heard of Cribble. I haven't had a chance to use it. It's not, that's not open source, is it? Yeah, no. Okay, so then all we have to do is sudo systemctl restart the Waza agent, and then we're good. That'll start sending suricata data into our sock. So we're gonna run, we're gonna go ahead and hit the alert, or we're gonna trigger the most obvious alert here from our Windows machine, just to see it. There's this site you go to called Test My NIDS, which sounds really wrong. Or Test My IDS. Yeah. And that should trigger some alerts. And the way that we're going to do that is we search the Waza dashboard. Yes, yes, yes! Not only are we getting the Suricata, but we're getting the Zeek data too. Hell yes. So good. This has been a long time coming. See, Angel, thanks for hanging out. Oh, this has been a long time coming that we have all the packet capture stuff working. So if we want to see this actually, if we want to see the Suri stuff, I believe we have to search for the rule ID. Okay, it's not in yet. But if we do the tail for the fast.log, we should see... Let me rerun it, and we'll see. We should see it happen in real time, basically. It's weird that we're not seeing that come in just yet. What does Zeek do that Suricata doesn't? So they really serve different purposes. Zeek is pretty raw in terms of what it's pulling. It's parsing packet capture and giving you the data from the packet capture, basically. At least I hesitate to say net flow, but net flow plus, basically. So it does, you're tossing the payload of the application layer, and you're keeping pretty much everything else, right? You're keeping the TCP/IP. If there's DNS data, if there's HTTP data, it can show some of it. That's kind of where Zeek lives, is the kind of raw packet data, whereas Suricata it has a set of rules to detect on packet data for particular alerts, right? So Zeek doesn't have alerting. It has raw information. Suricata has alerting, but so does Waza in this case, right? So we have a couple of different ways that we can get alerting data. So that should be good. Seeing user log off. Let's refresh this. I'm a little concerned that Suricata isn't showing me this bad window update. That's very funny. Okay. Are we seeing the NIDS test, though? Look at this bad window update. This is all from today. Okay. And let's just focus in on alerts from SecLab Suricata, which is a thing you can do. We're not seeing the Suri logs yet, so let's see what's up with that. That might be a Waza thing. So sudo vim var log. Let me just become root. Sudo I vim var log. Oh, logs. A sec.log. Okay, it's analyzing the file. It found it. Don't call me bro. I do not identify as a bro. But J Beers, we are working on getting the Suricata and actually all packet capture interfaces working in Proxmox, and the packet captures are working. But now we're just getting the Suricata data in. Which seems to be taking some time. I think this might be a Waza configuration, though. Because I think the data's coming in. All we're seeing right now is bad window updates. Let's see if we can make something else happen. Go to taggerttech.com. Oh yeah, look at that. Those are working. Is it test my NIDS or test? I guess it is test my IDS. It's interesting that we didn't see that trigger, that rule fire. But the Tagger Tech visitor is working just fine. Yes! Okay, so we do have rules working. So the Suricata alert looks like exactly like this. And if we look at the JSON, we have the raw data, right? We have the source IP, we have the dest IP. Oh, that's perfect. Oh, good, good, good. Okay, so here's the trick then. In order for us to Ginta Man, thank you so much for the follow. In order for us to make this persistent, right? Because as I said, the mirrors that we just set up will not survive a hypervisor reboot. We're gonna basically create a script and put in all of the hard work that we've just done. So we're gonna make dir scripts, and then we're gonna vim set up mirrors .sh bin bash, and then I'm gonna just take what we just did here, this whole situation, boom, chmod plus x, set up mirrors, and then we're going to cron tab E. Obviously, we're using Vim. Okay. And because I so despise cron syntax, we're going to use good old crontab.guru. If you don't know about crontab.guru, it's a lifesaver. So crontab.guru will allow you to build your cron syntax dynamically. /2, right? Yeah. Every 5 minutes, I think, is sufficient. So we'll take that and right here, and then we'll put it in, we're going to run root scripts setup mirrors.sh. Yep. That's it. At long last, months of work, we actually have working packet capture going on in the SOC. We have sysmon data coming in. Let's clear this filter. This thing is ready to rock. We have And by the way, we have PF blocker NG set up on the router, right? We have PF blocker NG set up on the router, so automatic block lists for the router. We have an open CTI threat intel feed coming in. I have some work to do to pull in some latest data, but we have a threat intel dashboard in here that is working. And total cost of light, we have Suricata for intrusion detection, right? So we have logging going on. Obviously, we have Defender for, it's just not Defender for endpoint, but basic Defender. So total cost of licensing for the defensive tools, $0. Total cost in my life force that has gone into making this thing, probably about 25 years. But it's working. And so now we have a bit of a recipe to build out a SOC that is honestly fairly muscular with free and open source options. And that's what the objective was. And it's mostly reproducible. Now, with all this done, what I wanted to do for the rest of today was kind of pivot, because I came across the weirdest malware sample. And I wanted to show it to all of you because it's indicative of the kind of thing that you might come up against as a blue teamer, as an analyst, maybe as an incident responder. And it just might be a little bit odd for you if you see it. And it's one of those things where this might be a bit of a hot take, and if Husky's here, I'm sorry. Most of the time, if you are doing malware analysis during incident response, you are doing something wrong. Most of the time. Here's why. Incident response is very fast, and malware analysis is not. At least static malware analysis. Like, go ahead and sandbox it. But in an incident response, what you're looking at is behavioral artifacts from the system. And so if you have the original threat vector, if you have the original piece of malware that got on the system or the original commands that were run, you can follow that thread based on logging or other utilities that you should have in place. And that is where your focus should be, because you get to see what the thing did on the system. You don't have to run the thing in a sandbox. You don't have to crack it open in a disassembler to see that data. You can look at it in other ways. So most of the time in incident response, malware analysis is a waste of your time. But sometimes you have to do it because the malware is so weird and there may be gaps in your visibility or just the way that it works. You're not going to see exactly what it did or how it did it. And you have to crack that thing open. And when that happens, you want to have somebody on your team who's able to make that happen. Okay, later for you, OpenCTI. I'll deal with you later. Oh god, yes, we can close all of this. So let's bring up this malware sample. All right, so there's like a bunch of stuff that I have from the pull here. And most of this you don't need to see. But the thing that we do need to see is the not responsible for accidents agreement. Now, I will tell you just a little bit of backstory about how this thing came in. And it's something that I think we need to address much more in defense. we spend a lot of time talking about 0 days. We spend a lot of time talking about, interesting Windows Active Directory attacks. We spend a lot of time talking about even phishing. Yeah? But there's another class of threat vector that I don't really hear anybody talking about. And as far as I can tell, it is the biggest danger on a day-to-day basis, even, I would say, even bigger than phishing, to most users. And I'll just ask the chat if anyone has any thoughts as to what that might be. Other than phishing, other than 0 days, what do you think the biggest threat facing our users might be? Drawing a blank themselves. Don't blame the users. Don't blame the users. If we can't protect them, that's on us. No, it's search poisoning. Search poisoning. Here's why. So what we know is that there are a lot of malicious actors that are using SEO and maybe even promoted advertised sites for specific search strings or search categories to get their search results up higher in those results. And users click on it and they will end up downloading stuff to their machine because it's what they were looking for. And when you do that, right, just the mental process is like, once you're searching for something and you go to get it and it's given to you, you are kind of bypassing some of those vigilance techniques, because it's not like it was given to you. You had to go find it, right? It's one of those things like people believe information that it's harder for them to find. And so if you've gone to search for something and you've now acquired it, just unless you're thinking about it this way, like, where's the threat? You went to find it and Google provided you with the search result. Google wouldn't give you malware, right? But they do. And this is why. It is rampant and it is hard to defend against. Yeah. And so this is one of those things. A user was looking for a specific kind of form. It doesn't really matter. But a user was looking for something specific. A search result was providing exactly what they were looking for. They clicked on it. They downloaded a zip file. The zip file contained a JavaScript file. Okay? Now, .js. If you're not familiar, Windows has a fork, truly a fork, of JavaScript called JScript. And what JScript does is it gives you a way to execute JavaScript right on the freaking desktop. In fact, to this day, .js files are marked as executable on the desktop. Trying to find like a message box. I'll leave it alone for now. But the point is, oh, hey, Dan, thank you. Bypassing mental vigilance. Found what I was looking for. Yeah, no, it's true. And this is like a known thing in social engineering, and spies and like tradecraft folks have done this forever, where like you can't give false information too easily. If you give false information too easily, then nobody believes that it's real. If you make it, if you make the person work harder to get it, like make the interrogation harder or make it harder to find in one way or another, people are more willing to believe that it is true. This also has a kind of insidious side effect with conspiracy theories, because if you have gone down some sort of like rabbit hole of research and you found like really obscure stuff on the internet, because you have put so much effort into looking for that stuff, no matter how out there it is, you are more likely to believe that there's something real about it because of the effort that you've put into it. It's a really amazing logical fallacy that people fall prey to. Okay, so this thing, I want to look at it statically first, because I think you'll be amazed at what it is and what it looks like. So I'm going to move this thing. And we're going to call it WTF.js, and you'll see why. Okay. Where are my web folks at? What does this look like? What does this look like? It's jQuery. jQuery is a real thing. jQuery is absolutely a real thing. jQuery is what you would use before we had more modern ways in the DOM API of actually, not JS query. Thank you. jQuery is what I wanted. This is real. Right? You can just see this thing. And it's a JavaScript 3.6. Okay. Let's go look at it. You often block jQuery. It's rarely required to contact the domain, you thinks? Yeah, Enervite. That sucks. You are making life really tough for your users. Now, it's maybe a good idea, but sites use jQuery to enable their behavior. So unless you're in kind of a weird environment where you can get away with not using JavaScript of any kind. Plus, most of the time, jQuery is delivered... Oh, only for yourself. Okay, well, most of the time it's delivered via CDN. Let's look at this thing. I don't want the minified. I just want the .js. So far, it looks pretty much like jQuery, right? And so I'm looking through this thing, and this was, by the way, we saw like WScript executions, right? So like I'm looking through this thing, and I'm like, and by the way, it's long. I looked at this. Like the whole file is in here, and I'm like, this is jQuery. What is this? I don't know. Like, did we miss something? What happened? Why was this the thing that triggered the alert? What happened here? And by the way, I would consider myself like not the best threat hunter by any stretch of the imagination, but I read JavaScript all the time. And I have done for quite some time. And it took me a couple times reading through the file to find this. But I gotta tell you, that ain't jQuery. Now, there are a couple of things about this that I wanted to call out. So obviously, you start seeing this kind of string concatenation and bizarre stuff, you know somebody's trying to pull one over on you, right? You just know that. But I want you to take a, like, when you think about JavaScript obfuscation, yeah, you see invoke web request right here, and there are a few others that are kind of giveaways. But when you look at this, what are some things that seem different to you if you're familiar with how obfuscation generally works? And this was interesting to me because I'd never seen something like this before. Hey, Owen. And maybe this was just my lack of experience with it, but I'd never seen obfuscation that looked like this, where it was noun number. Yes, exactly, Yanner. I've never seen that before. I'm used to seeing obfuscation where it's just like random characters put together, right? But this was using plain English words. And I have a theory as to why they did it, and I think it's actually a pretty clever idea. But I'm curious to hear your thoughts. Why do you think that the malware authors did their obfuscation this way? I don't think it was laziness. I think that they were being clever about something. This originates from an obfuscation to avoid name tagging replacement in analyzers. I'm not sure what you mean, Payload Viking, but I do think that, yes, it's obfuscation. I understand that's what it is, but the I don't think it's SEO. Although that would be funny. I think it's to break entropy detection. Meaning that you're adding a bunch of entropy to your file with crap like this. But by adding your obfuscated variable and function names will also add entropy. So an easy way to fix that is to use your obfuscated variable and function names is to make them plain English, right? This has much lower entropy, if we were to analyze it that way, than normal obfuscation. So yes, you're kind of like, you're increasing your obfuscation score with the, you're increasing your entropy with the actual obfuscation done inside here. But this is a lot less entropic. So I think this is a wildly clever way of doing it. Now, you want to fire this thing off and see what it does? Why do we have the lab if not for stuff like this? Okay. Can I get it onto my jump box? Is the question. LT. There is a hell tea. It is the yogi tea, ginger tea. I've never had a tea make me vomit, but that one did it. That stuff is gnarly. Yes. Okay, awesome. So we have WTF.js, and now let's go deliver it to our unwitting target. We're going to use our workstation, but before we do, we're going to snapshot this bad boy so that we can clean it up. Yeah, Yanner, neither did I. It was not a great experience. And it was like a decade ago and I still remember it. All right. For those of you who have just joined us recently, by the way, I don't know if you know this because I can't stop talking about it, but hey, I released a course this week on practical web app security and testing. You can get it at TCM Academy. It's 9 hours of really great introductory material to becoming a web app pen tester. Not just how to do the attacks, but also how to build the pen test report and how to use Zap like a professional. So if you're interested in that, go check it out there. Today, until midnight tonight, you can get 50% off with code HackerDay50. That's right, Zap Gang. All right, we have a snapshot. Defender is on. Right, Defender is on. What do I think about TCM Academy? Well, obviously, I like them well enough to publish my material through them. I think that Heath and the rest of the team are doing fantastic work. They are lowering the barrier to entry to really solid offensive and defensive cybersecurity training, mostly offensive right now. The PNPT exam is, I haven't yet taken it, but it's, from everything I've heard, really phenomenal as a starting point. And as an alternative to OSCP, it's much more practical. And the fact that after you take the exam, you get a feedback session with a tester, right, to talk about how you did, what you could have done better next time. Like, that's really cool. Also, free retakes, not for nothing. That's kind of a big deal. At a literal fraction of the cost of OSCP. I like PNPT a lot. And, of course, two of my friends, Mayor Joe and Husky, of course, have released courses through them. Mayor Joe has movement, pivoting, and persistence, the Windows pen testing course, which is really cool. I learned a lot from that course about how to work with Active Directory and how to move through it as an attacker. Really, really important if you're doing that kind of work. And then, of course, Husky's practical malware analysis and triage course, also phenomenal, right? I learned a lot about how to do this kind of stuff from Husky. So yeah, I'm pro TCM. All right, Defender is on. And we're also, by the way, we're going to do this in two ways. We're going to use... what? Why? We're not just going to use our own lab for this. There's no private information in this thing. So we're also going to give this thing to Hatching Triage. And we're going to compare our notes. All right, so we're going to submit. Well, I will give your course a chance. Let's have a look at it. Well, thank you so much for your generosity, Payload Viking. Your largesse knows no bounds. I mean, in all seriousness, I hope you enjoy it. All right. So we're going to fire this thing off and Hatching Triage. We're going to give it a Windows 10 system. Internet access on. Go. And then meanwhile, okay, thanks so much, KDE, for opening that. All right, so notice that we've got this WTF.js, and notice that if we just look at the permissions for this thing, there's execute. Let's make sure the sock is up and running. I really wish that would stop happening. Okay. The static analysis should be done in triage. No score, real helpful. Does virus total have anything for us? Just search the hash here. Nope. Brand new sample. I always wonder, does this thing... Because I can interact with this. Does it show me the thing? Looks like no. Unless it's mounted in some other way. Nope. So I got an 8 from Windows. Oh, okay. Ha 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 ha. Block listed process makes network request. Awesome. Show it to me. Let's see if we see the same thing. Off you go. I don't know why that's happening. Okay. Let's go ahead and refresh. And I'll focus in. Zeke shows an SSL connection. 20815195. That's 46. See what else is going on in here. And this is a situation in which I did want this thing to actually have some network, because I wanted it to make these network requests. Hey, we've got DNS queries. Let's show me the query. No, why would it? But this is just Zeek data, right? Now I know that if I were to go over and look for events, I should be able to see some stuff in Sysmon, right? I should see network connections. Itachi Baru, this is the Waza plugin with Elastic and Kibana. So it's Elk, mostly. Hey, look at this. We've got ZD workstation. So we're going to focus in on what's going on the workstation. We're going to add that filter. And this Windows based script host, that's I would argue that should be a bigger deal. Look at this though. Oh, so much good stuff going on here. So we kicked this off around 40, right? Search protocol host, that's not a big deal. DLL host, though, maybe. Notice that got a score of 12. The parent process ID was 848. Interesting. Okay. Some more process creation. This script host, though, right? This was the first thing that happened, right? I kicked off this WTF.js. That was the first thing that happened. Shortly thereafter, DS-Reg, that might not be related. Let's go ahead and refresh this. See if we saw anything else happen. Yes, that is correct, Angel. You would match the process tree of the parent command line to see the execution chain, but keep in mind that we found the first thing. Right, the first thing is right here. Because we know the trigger was the WTF.js. So we're still... Care to try that again? So we're looking to see this thing. There are no results for the expected time range. That's different. It's like we lost agents here. What happened? Everybody's good. Oh, wild. That is concerning. But I don't know if that's... Did I just have the time filter messed up? That's better, I think. Yeah. Hey, look. Okay, this is what I wanted to see. So, okay, there's our script-based host. Here's our network connections. Let's see what we got. 46, 235, 226.209. Well, hello there. Then what happened? Remember, just because something happens next doesn't mean that it is directly related. So this event, we can see here that the process ID is 7280. And we can actually filter for this value to see everything that that process ID did from sysmon logs. So that would be the next step, as Angel correctly said. What did that thing do? But it looks like that 7280, that's actually pretty low. That may be a... Oh, here we go. There we go. Just took a second for the filter to apply. So we've got these network connections coming in. And then what's this sysmon informational event? DNS query to labbunnies.eu. Now, was that one of the ones that we saw? No. Awesome. So we actually have some new observables. There's Lintel Consulting, which we saw. Anything else? See if anything else has come in. Not so much. We'll clear out that filter just to see if there's anything new that looks interesting since that time. Since we know that they're using DNS events, like they're doing queries, it's entirely possible we might want to look at all the DNS queries that it's doing. Yep. And triage gives that to us as well, Yanner. Oh, for lab bunners. Yeah. So, by the way, oh, Dan, thank you so much for the subscription. By the way, if we're doing this quote unquote right, the next thing we want to do is add observables. Right? We have now generated new observables, which we would want to add to our threat intel platform. So we can track this to see if it happens again. Right? So if we go to observations, plus, we'll add a new observation, and it's a domain name. And we say found from jQuery masquerading JS file. labbunnies.eu. The author is not Alien Vault. Create an indicator from this observable. Thank you. And we can also add all the IP addresses, right? And that's really what you want to do, is start managing the new stuff that you bring in. And then the next part is that those then start getting added. Ideally, you can share that stuff upstream, right? And then you also are automating the connection of those indicators, the atomics, right? The domain names and the IP addresses. You're automating that stuff into your block lists for your firewalls. All of that should be automated from your discovery. Once you add observables, all of that stuff should just go, right? And that's what makes this kind of defense system work seamlessly, so that, okay, catch it once, it won't get through again. That's really what you want to have happen. And you want to have the monitoring to be able to catch it when it happens. What is this? Identity helper. What's this other informational event? Was this Lab Bunnies? I think this was. Oh no, this is Lenovo B2 portal. So it's cycling all sorts of different ones. Was Lenovo one of the ones that Hatching saw? No. So that's another one that we can add. Now, if you want to be really cool, you can submit this upstream to Alien Vault or other threat intel places where you can, like, you can create pulses yourself. And should I be labeling these? Yeah, probably, but it's fine for now. So I think that's kind of like what I wanted to show you, right? Because it doesn't look like we're getting any additional execution on this. And sometimes that happens, right? For whatever reason, it doesn't kind of play ball. Now we have Zeek data, right? We have all sorts of Zeek data that we can look at here. I'm going to kill this now by rolling our machine back. This should disconnect. Yeah, it might lie low for a while. It might have detected your environment. All possibilities. It could have detected that it was a virtualized machine and have a shutdown. I will tell you that, you know, from original detection, we didn't see it do anything else either. So it may also have detected like EDR or something else and decided not to play ball. all possibilities. And to do that, to answer those questions, that's when you would go to your static analysis and find out what the code was doing, all of that bizarre stuff that we saw in the JavaScript, right? Which we can do. Right? That was kind of the dynamic aspect of it, but we go look at wave 4. Notice that there was a bunch of these others, like C2, Village 6. But this appeared to be the thing. So we can do a couple of things with this. First of all, we're going to do a tab E here. Defanged.js. This is where we get into the fun stuff. Is there a way to detect what kind of obfuscation framework, if any, that was used? It's possible, Angel. I'll be honest, I don't know enough myself about those kinds of obfuscation frameworks to tell you what might have done it. This one, the reason I'm sharing this with you today is because this was so weird to me. I'd never seen anything like it. But like, you could write an obfuscation technique like this in a couple of lines of Python or in JavaScript. So what we're going to do is we're going to take at least wave 4 for right now, just to start this function. I'm going to paste it in here. And obviously, what are we seeing here? It's doing a lot of string obfuscation. It's doing a lot of like splits, things like that. Okay. And then it's combining them together. And then it's calling this function half6. Well, we're going to comment that out for right now. But what we are going to do is we're going to do console.log chart6, which is the first string that it's doing here. In fact, let's do a new line so that's clearer. Right, weather 9. Thank 2 looks like. Or quick 9, yeah. So there's a bunch of them here. Yeah, hey killer. This is the sample that we were just running, but I wanted to show it run first, right? Now, if this were, C, I couldn't do this. But because this is JavaScript, I'm in my happy place. I can work through JavaScript all the time. That's fine for me. So if you look how this is getting put together, Meet 4 and Chart 6 appear to be kind of the big ones here. So we're gonna console.log out Meet 4, and we're also going to console log out Meet 4. We're going to console log out root 7. No, actually meet 4 is pretty much all we need, I think, to start. We're just going to console.log that out. And, and then we're just going to call wave 4 here. Right? There's function wave 4. And then, please tell me I have node installed. God. Damn it. That's fine. I keep thinking I have node installed everywhere, and I don't, which is a huge pain. So rather than go through the trouble of doing it this way, I'm going to go get the Linux binary. Ah, cute. So it goes to install node, accidentally reinstalls this funny looking JS instead. That'd be interesting. I mean, I could technically just run this in the console in a browser. Oh no, village 6 is not defined. Yeah, no, I wasn't about to give this to a website like, here, enjoy this, malware. Although that would be funny. Wave 6, village 6 is not defined. Okay, so we need village 6. Welcome to malware analysis. Okay, so we need village 6. So let's go find it. I'm not Hammond. Equals C2. All right, looks like we're going to need town. There's village 6 defined. There's village 6 again. But I think we need to do the... We need to find the original village 6. There it is. Okay. And then represent 0 is the other thing we have in here. Represent 0. So let's go get represent 0. Which itself, now we're starting to put this thing together. Okay, which itself requires half 6. Which finally we found something that doesn't have a separate function call. Okay. Yeah. Why do I keep typing C? RM changelog, RM license, RM readme. So the way that you're supposed to install this thing this way is you're like your CP RF to user local. For some reason I can't type my password. And now I have node, right? Okay. So now, documents, malware. Okay, see sample. Okay, we're gonna, if we do node wtf.js, nothing. Oh, wait, no, that should have worked. Oh, no. It's node defanged. Do I have to write this thing? Yes. There you are. Village 6 is not defined because we have to call the thing that defines village 6, which is path 4. So we're going to call path 4. And then we can call wave 4. Okay. Face 8 is not defined. Next up, we're going to go find face 8. Function face 8. So it looks like we're going to have to get the whole kit and caboodle here, but that's okay. So now we know we need suggest 8. Chat, is this of interest? Just want to check. Is like, I know that this is kind of a slog, but, you know, is reversing this malware of interest to us? Okay. We also need pass 8. And by the way, it might seem wacky that I'm using Vim for this, but I gotta tell you, with the search capabilities and everything else, I actually love Vim for this work specifically. I find it very efficient. I find that I can work very cleanly this way. And if I needed to split the windows back and forth, I could do that too, but... okay. Clock 6. Other way around. Bravo. And Clock 6 doesn't look like it has any references. So yeah, Shift ZQ works, Shift ZZ, but no one knows the watch this. No, not what I wanted. X is save and quit. :X is save and quit. So Node is defect.js is running, but it's hanging on something. So here's what we're gonna do. We're gonna toss some consoles in here. And this will give us an idea of where we are in the execution. It's not as cool as a, debug breakpoint, but it works. How was everybody's week? Mine was a little nuts. Okay. Awesome. So you see we're going path 4 represents 0, half 6. You're doing a lot of data science and machine learning stuff? Boy, that's what I'm learning next, Wally, and I am I'm looking forward to it, honestly. It's something I've wanted to dive into for a long time. Okay, so it says while allo is less than fire1 times 4748. So fire1, are we defining that anywhere in here? Oh, it's whatever half 6 was called with, right? So let's go to represent 0, half 6, 83, H6. Awesome. Yeah, scikit-learn and TensorFlow. That's rad. Killer, you went to a concert. Very cool. L equals 92. L plus plus. While L is fire1 times 4748. And fire1 is 83,795. That's very large. Is this just a timer? Because we can short circuit this. We can just say allo equals fire1 times 47, 48 plus 92. I don't know why. That's interesting, but we're going to comment that out. You power wash 7 houses. That's crazy. Oh, you're doing a machine learning based IDS. Wally, I am very interested to see that research. Let us know when it's finished. If you can. I want to read that paper. Okay, now that it's not doing that weird loop, let's see what happens. Oh, so it's still like dying on half 6. Half 6 while... Okay, so it's actually dying here. While wave 4 equals... While wave 4 equals wave 4. Equals wave 4. And wave 4 is a function. But while... That's interesting that it's a single equal sign. I didn't mess that up. They're not super common, Cheeto. They're around, but, you know, I want to know what new people are doing with their research. I'm interested in reading it. And also, frankly, AI has a lot of room for improvement when it comes to this sort of thing. There's a lot, even in what we have, there's a lot of underfitting and overfitting of models. And even the training sets are not either not sufficient or not properly mapped to the problem. That's really cool, Bravo. Power washing, carpentry, rail installation. That's really cool. I'm a huge booster for the trades. And by the way, if you think that programming isn't a trade, it definitely is. Like, it is to me the same sort of thought process and kind of work as joinery, honestly. The market values it right now, so whatever, but like, I don't know. It's the reason I like it is the same reason that I liked working with my uncle who was a carpenter when I was a kid, which is you're building something, right? You're making something with your own 2 hands and your brain. It's the same, for me, it's the same sense of satisfaction. Okay. So while wave 4 equals wave 4, this is weird to me because this is an assignment, right? This is like while true. Try village 6, exercise 93, catch total 7. Village 6 equals wave 4, exercise 93 plus. So village 6, exercise 93. And do we have exercise 93? Yes. Equals 6683. Now, actually, I'm being stupid, I just realized. Because guess what? There's a really easy way. Do I know GNS3? I don't know GNS3. Is that like GPT? No. Your virtual network in a suitcase. Real-time network simulation. Is this a network simulator? It's like a virtual environment for networking. That's cool. I'm interested. We've done some packet tracer stuff on stream. Oh yeah, this looks cool. I'm into it. How would you say it compares to packet tracer? Anyway, so I realized it's like packet tracer, but with real iOS images. Whoa, how did they pull that off? Okay, so I realized that there's a way that we can get every single function in the sample. All we have to do is look for 0 through 9 and a curly brace. What? Or no, it would be like 0 through 9. So function dot plus, right? Actually dot plus, and then 0 through 9 regular expressions, baby, and then a little parenthesis. Yep, there it is. Packet tracer isn't like, it's ancient, but it still works. Okay, so there's half 6. Yard 7. Let's go get that one in there. Hundred 0. So I'm just looking for all. There's represent, suggest 8, which we have. Substance 2, that's new. So yeah, I'm just using regular expressions to find all of the functions. I don't think we had hound 2. That's a big deal one. GNU Step, thank you so much for the follow. Giving away my Linux GNU nerdery with that pronunciation. Pass 8. Do we have pass 8? Yeah, we do. There's wave 4. Path 4. Yeah, we have path 4. Clock 6. Love 1. Love 1, y'all. Side 5. This is absolutely the kind of thing that I never have time for. during incident response, right? You can't take the time to do this during incident response. The question is, what's happening? Is the system impacted? Is there lateral movement? What do we do? Contain it, get rid of it. C2. So funny how this is written. I think we have half 6. Yeah, we have half 6. Yard 7. Ooh, this looks like a big deal. Are you looking for what functions are called so that you know what to remove, or just the program flow? So what I'm doing, Killer, since these are all so interrelated, is I'm pulling out every single function. Represent 0, suggest 8, substance 2, town 2, pass 8, wait 4. Yeah, okay, we got all of them. And I'm getting every single function. So basically, I'm defanging it, and I'm trying to execute it to see what it does. It's still hanging at half 6. Which really is hanging because of it's hanging from this while. And I feel like this is just like bad code. But I guess not, because we saw the domain controller. Or the domain controller. Ugh, the domain name, the DNS requests. Nope, that didn't matter. So village 6. We're gonna, so clearly we're gonna have to console.log village 6. We have to see what's in there. I gotta change that mouse binding. Village 6. Just says 5388. So now what I want to look for is a 0 through 9. I want to see the order of calls here with a parenthesis. All right, look at that. So path 4, 5924, this is the kickoff. Is anything useful for deobfuscating these in a semi-automated way? So there are JavaScript deobfuscators that can detect specific frameworks. But I don't know if this is going to work for this one. Yeah, I use this thing all the time. And like, we can try it. That's interesting. I didn't. Shift V, G, there we go. But it's not. Oh, damn. It did help us out a little bit with that. That's cool. Oh, but no, that's just the strings we already saw. Now, it does make it easier to read. Yeah, no. So unfortunately, yeah, it's just not. Obfuscated binaries is the same as stripped binaries. No, they are not. Obfuscated binaries can be packed or can do other sorts of weird stuff where you're actually doing like specific code operations to make the code harder to read. Stripped binaries, all that means is that their debug symbols are taken out, which means that the function names and other things that you would normally see in a binary that had those debug symbols inside of them will be available to the disassembler. So that's the difference, for example, like if you ever do a binary exploitation challenge, that's the difference between disassembling it and getting the function names and then disassembling it and just like getting like random numbered functions that are the offset of the function. But there is no such thing as a stripped. These are not binaries, right? These are just scripts. Okay, so now that we've given... All right, let's see what the next one is. Path 4. Yeah. So half 6, 2389, which we have. I'm looking for any of these that are outside of function calls, right? Because we have all these. Yeah. Half 6, 54, 72. So this 5924 is the kickoff, and that is something that we didn't have before, but now we do. It's still hanging at the same place. Wait, did I make the change? Yep, still did. Okay, so but obviously path 4 is like the first thing that needs to happen. So let's look at what path 4 does. Village 6 is set to 5388, which we saw before, and then it calls represent 0 with village 6, which we saw before. So let's go back to that represent 0. Okay, listen 4 equals face 8. Exercise 93 equals 663. Exercise 93. Is there like, this is a question, is there like a node trace? Yes, there is. trace events enabled. Nothing. But we can do, okay, so the way this would work is I'm gonna do const trace events equals require node trace events and const tracing oh no, we don't have to do that. No trace events enabled. So I'm looking for a way to get trace, like I want to see what the engine is doing. Yeah. Trace. Trace events enabled. Track heap object allocations for heap snapshots. I don't need that at the moment. That would be crazy. Nothing. It's interesting that this one runs and this one doesn't. You know? Yeah, still hang on that represent 0. Now it's interesting that we had to, so path 4 is called with this number, right? But notice that it doesn't have a value passed in. So there's something else going on here. I was just curious if we could find bunnies or something like that in the strings here. But no, this is pretty well obfuscated. See if any more logs came in from the sock. I doubt it, but just to be sure. I mean, we reset the machine, but I just want to see if anything else was picked up. I think it was pretty much just the network connections and then it died, right? Deobfuscate with document.write. Say more about what you mean by that, Dan. These are strings that are meant. So here's the thing. This is not meant to be run like. What we could do, I don't have the tool for this right now, but what we could do is fire this up in like WinDBG and see how these strings get pulled when we run it on Windows. But wait, hold on a second. Hold on a second. Can I just call wave 4? Because what happens if I do that? Because all this stuff is defined, right? Yeah. It says village 6 is not defined. All right, well, we know that path defines village 6 this way, right? So let's just go ahead and shim that into wave 4. Just like, whatever. That's pretty much just the whole thing put together. I doubt this will work, but we will try it. Wow. That actually worked great. Or did it? No, because it's not VB script. Yeah, no, the trick is... Okay, so this is how... Okay, so half 6. What does half 6 do? As we uncommented this, or we commented this out. But plainly, half 6 is what happens next. So, what does half 6 do? Okay. No. Half 6. Right, it does this thing. Oh, interesting. Does that change it up at all? Doesn't seem like it. Now, I think we're going to call it there. Kind of at the end of my time. But obviously, some pretty cool stuff going on. We did see at least dynamically what it was doing. We were able to generate some new observables from it. And it is a new kind of obfuscation that I haven't seen before. So be on the lookout for that. If something appears to be jQuery or just a straight up JavaScript file, obviously be aware of the fact that it might not be, especially if you're getting alerts. And yeah, now we have a SOC that is doing what it's supposed to do. So good news there. Thank you so much, everybody, for hanging out. I had a great time today. I hope you did. Let's see. I think we're going to give Christy a raid here. And of course, I will be back on Tuesday doing some Red Team stuff, and Wednesday doing some more programming. So if you're into that, we'll see you at 5 p.m. Pacific on those days. And Tuesdays, as always, I'm here doing Blue Team. So until next time, friends, please be good to yourselves, be good to each other, and happy hacking. We will see you next time.